Hello guys, welcome back to a new session. So this is formula sheet on differential equation. So differential equation has just methods. There's no such kind like formulas. So I will be telling the basic definition, few definitions and the methods in this session. So let's quickly get into the video. So yeah, and yeah, first let me tell about order of a differential equation. Generally, you will have an idea about what is a differential equation and what is not a differential equation. So, order of differential equation is nothing but the highest order. So, basically, highest order means, for example, d square y by dx square plus dy by dx is equal to 0. So, here your highest order derivative. So, here your highest order derivative here is 2 because this is second order and this is first order. Among this, which is the highest order? Which is 2. Okay. Now, degree of differential equation is nothing but degree or the power of the highest order derivative. For example, in the same sum, if I put this as square and this as cube. So here, what is my highest order derivative? 2 is my highest order derivative and I have to check its power. Its power is 3. So degree of the differential equation is 3. So these are the basic things which you definitely have to know. Now let's go to the variable separable form. So variable separable form is any differential equation is of this kind. Which means you are able to separate your x function and your y function. You are able to separate your x function to one side and y function to other side. Then you call it as variable separable. So after separating, what are you supposed to do? In order to find the solution, you are supposed to integrate it. So these are the types of differential equations which I am going to tell you. And how are you supposed to solve the corresponding types and find the answers? That is what I am going to tell, because that is what is there in the formula section of differential equation. Now, reducible to variable separable. Any differential equation that can be reduced to variable separable. For example, when any differential equation of this kind, when you are having dy by dx that is equal to f of ax plus by plus c. So here I am able to reduce it to what? My variable separable. When am I able to reduce it to variable separable? When I substitute the whole thing as v. When I substitute the whole thing as v, I will be able to get it. So when I substitute the whole thing as v, I will be able to come in the form of variable separable method. So this is the kind 2 of solving differential equation. Now kind 3. Now homogeneous differential equation. So this is about homogeneous differential equation. So when you say a function is homogeneous, if you are able to express a function in terms of, if you are expressing lambda x comma lambda y in terms of lambda power n, if you are able to separate the lambda from the function, then you call that function as homogeneous function. So here lambda is nothing but a non-zero constant. Okay, and now the differential equation of this kind is said to be homogeneous if you will be able to write your dy by dx of f of x is equal to g of y by x. So basically it will be in the term of y by x. So basically if you are able to separate the lambda, you can tell it is a homogeneous function. If it is homogeneous function, you can write y by x. So instead of y by x, instead of y, what can you write? If your equation is of this form, if your differential equation is of something, a function that is written as y by x in terms of y by x, then you have to substitute y is equal to v of x. Then what are you going to do? Then you're going to integrate it. Then you have to reduce in the form v plus x dv by dx is equal to dv. G of v. So now what? Then again this is of the form variable separable. So I am taking this term to the other side and I am going to separate it and integrate it. Okay. So now this is of the form variable separable only. So here basically remember that you have to put y for homogeneous equation. You definitely have to put y is equal to vx. Then write in terms, you have to write the equation in terms of v and x. After writing in terms of v and x, what are you supposed to do? You are supposed to integrate. After integrating, then you are supposed to replace your v with y by x, because we have written y is equal to v by x. So the equation which you got in terms of y and x, that is your solution. So this is for your homogeneous. Now let's go to linear equation. In linear equation you have two kinds. Okay, linear differential equation. I mean P and Q in terms of constants, or you can say or functions of x. So if p and q are constants and function of x, if your differential equation is of the form dy by dx plus py is equal to q, where p and q are some constants of x or functions of x, then what are you supposed to find? You are supposed to find a factor called integrating factor. So integrating factor, you are able to find if is equal to e power integral p dx. Okay. Now, after finding your differential equation solution can be found like this: y into integrating factor is equal to integral q into integrating factor into dx plus c. Okay. Now, what is second kind? Second kind, if your differential equation is of the form this one. Here you have written dy by dx. Here it is dx by dy plus px is equal to q. So here p and q are functions or constants of y. Okay. Then how is your integrating factor? You can find the integrating factor as integral e power p dy. Okay. Then your x into if is equal to integral q into if into dy plus c. So this is how you're going to find the solutions for it. So that's all for today's, that's all for the formulas related to differential equation. I hope you understood it. Basically, these are the methods in which you are able to find the differential equation. I am just told what is the basic thing, which is order and degree. That's it. I hope you enjoyed it. Thank you, and it's bye from Harismita. Bye-bye.